Hello, Assalamu alaikum. This is Sir Talha. Welcome to my channel. So let's start with the chapter number 4, chemistry, P block elements. P block elements. Similar to the S block elements, P block elements are those whose electronic configuration ending in the p orbitals. All right. Elements whose electronic configuration ending in p orbital are called p block elements. Okay. So what else? There are total more than 30 elements. More than 30 elements in P block. Out of all those elements in the P block element, one is only liquid. The liquid element is Br, beryllium. 9 are gases. All out of P block elements, 9 are gases, 1 is liquid, and rest are solids. Okay. And P block contains all types of elements like metals, also non-metals, and as well as metalloids. So now starting from 3A group to 8A group, all elements are of P block. Boron, aluminium, gallium, iodine. Okay, similar to this 4A, 5A, 6A, 7A. All elements are of P block elements. I'm not writing all the element names. You know it well. I'm writing the general characteristics of the P block elements. As we have discussed, the atomic radii of S block increases down the group. So similar to that, atomic radii in P block also increases down the group. These are the trends, okay, that you have to remember for the MCQs. In all P block elements, atomic radii increases when we go down the group. Electronegativity, what has the effect on electronegativity? So electronegativity decreases when you are going down to the group and increases when you go from left to right in a period. Okay, electronegativity decreases down the group and increases from left to right in a period. Talking about the melting and boiling points, melting point and boiling point have no regular trends in P block elements. Okay, because why? Because they have both metals and non-metals in P block. and gases also. So there is no trend for melting and boiling point. They can form both colored and non-colored, means colorless compounds form both color and colorless compounds. And exist in polyatomic molecules. All right. And the last is they are not good conductors or bad conductors of heat and electricity because they have gases, bad conductors of heat and electricity, except metals. All right. All the metals are good conductors of heat and electricity. So talking about extraction of aluminium. Aluminium is an element, basically a metal, which exists about 7.3% in earth crust. So this is a good amount of aluminium present in the earth. So the important ore which is extracted from the earth is known as bauxite. You make aluminium through bauxite. Bauxite formula is Al2O3 and H2O. Bauxite and cryolite. The second ore is cryolite. Formula is Na3 AlF6. This is the formula. Okay. The extraction takes place of aluminium from this bauxite ore in two steps. First, we will be purifying the bauxite of alumina and then electrolysis of aluminium. These are the two steps. How it looks like: bauxite purification can be done by three methods: Hall's method, Byers, Serpex. These are the three methods from which bauxite can be pure. We can pure bauxite to get aluminium. In Hall's method, what we are using, when the core of bauxite contains iron Fe2O3 with silica. Silica is SiO2 and iron and silica. And ore contain iron and silica impurities. Okay. Then bauxite is finally diffused with sodium carbonate to form aluminate. Sodium aluminate is formed in by if we are proceeding from Hall's method. Equations are not important, that's why I'm not writing it here. The second, talking about Byers, if ore of bauxite contains impurity of only iron Fe2O3 impurity, okay, only iron impurity, then we will be going through Byers method. Okay, in this method, bauxite is then divided, treated with strong caustic soda. Caustic soda is used in that method. In Hall's method, what is being used? Sodium carbonate. Okay, in this caustic soda is being used. And the same sodium aluminate is formed by the Byers method after treating with caustic soda. Final is Serpex method. When only impurity is silica, then we use Serpex method. Okay. In this method, simple nitrogen is used and heated, and the reaction is heated at 1800 degrees centigrade. Okay. And mixed with the silica impurity is removed, and the bauxite mixed with the nitrogen at 1800 degrees centigrade to form aluminium nitrate. And this aluminium nitride is formed. And in both of these, Halls and Bayer, sodium aluminate is formed. By all these three methods, the last which we want for the electrolysis, sodium aluminate is obtained, okay, from the ore of bauxite. The next method is you have done purification and you have got the alumina. This is called alumina. Now what you have to do is to electrolysis of pure alumina. Okay. What you have to do in this, we mix alumina. Alumina is mixed with cryolite and fluorspar. These are the two things which mixed with the alumina in a steel tank with graphite lining. It's not important, just for the information. Okay. With a graphite lining. Okay, I'm writing this lining. Anode and cathodes are, because at electrolysis there must be one is anode and the other is cathode. So both are graphite. Anode is also graphite and cathode is also graphite, because we have covered the steel tank with a graphite lining. Now, on passing to the current electricity by this electrolyte material, aluminium is obtained at cathode. Okay, the things which I'm writing are important for the Ecat only. The rest theory is not important. How is obtained in liquid state? Obtained at cathode in liquid state, and then it's been drawn out to the tank. Why we are using cryolite? Why we have mixed cryolite with the alumina? To lower the melting point. Lower the melting point. And why fluorspar is being used? Cryolite is used for lower the melting point of alumina. About 950 degrees centigrade, lower the melting point. Cryolite is used for to lower the melting point of alumina to 950 degrees centigrade. And fluorospores increases the fluidity. What it does, increase the fluidity of the melt. So during this process, the graphite anode are consumed. The graphite at the anode is consumed. After this electrolysis, we will be doing refining. Refining of aluminium through Hope's method. Hope method. What we'll do in refining, about 99% pure alumina which is further refined in an iron box. We are using iron box with carbon at the bottom. Okay. Iron box with carbon at the bottom. Okay. How iron box is arranged? Iron box has 3 layers of fused mass. The lower layer consists of an alloy of impure aluminium with copper. I'm drawing this. Iron box. This is the iron box. Okay. It has 3 layers. 1, 2. The last, this is 3. The lower layer consists of an alloy of impure aluminium with copper. Impure with copper. Okay. Then the middle layer has, this is the middle layer. It has cryolite and barium fluoride BAF2. This is the chemical formula of this. Okay. And the upper layer consists of pure aluminium. This consists of pure aluminium. This is the cathode. Service cathode. On this electrolysis, we get 99.99% pure aluminium. Okay. Now talking about the uses. Uses of aluminium. Aluminium is used in the manufacture, used to manufacture electrical transmission wires, electrical wires. Okay. And bulbs, instruments, jewelry, aeroplanes, petrol, all these things contain aluminium. Jewelry, aeroplanes, and many other uses are for aluminium. The next manufacturing is about to manufacture the nitric acid. We used Ostwald process to manufacture the nitric acid. For nitric acid, commercial preparation, we start with the oxidation of ammonia in the presence of platinum catalyst. We are using the catalyst as a platinum. What does catalyst do? Catalyst fast or slow the reaction without taking any change in the reaction. Okay. So catalyst Platinum is a catalyst to form NO first, nitrogen oxide, which is turn produces NO2, and then it's ultimately converted to acid. Okay. The questions, the reactions are not so important. That's why I'm not writing it. Then after this, the volume of ammonia mixed with 8 parts of air enters into a converter where the platinum acting as a catalyst. This is the brief description that I'm telling you, not so important for your ECAT test. So what happens? I'm repeating the description. In the Ostwald process, first part of the volume of ammonia mixed with the 8 parts of air enters into a converter with platinum acting as a catalyst. There is a converter in which only one part means आप ये समझ लें कि एक हिस्सा एल्यूमिनियम का जा रहा है और 8 हिस्से हवा के जा रहे हैं, एयर के जा रहे हैं कन्वर्टर के अंदर और उसमें प्लेटिनियम एक्टिंग एज अ कैटलिस्ट. Then ammonia is oxidized to NO. Ammonia is then oxidized to NO. Then it is passed through a boiler to reduce its temperature. You're passing NO to from the boiler to reducing its temperature. Then NO is further oxidized. Then we are doing further oxidation of NO to form NO2. Okay, you can see it here. NO2. From NO to NO2, we are oxidizing. Then NO2 is dissolved in water to obtain about 68% concentrated acid. 68% concentrated nitric acid is then obtained from NO2. Further concentration can be achieved. We can achieve a further concentration by passing vapors of nitric acid over the sulfuric acid. Okay, these were the process, and this was all from the manufacturing of nitric acid. I'm talking about the uses now. So uses, nitric acid is used in the manufacturing of fertilizers, and ammonium nitrate, sodium nitrate, also in the use of nitroglycerine, smokeless gunpowder, and also nitric acid is used to make aqua regia, which can dissolve noble metals like gold. These all are the uses of the nitric acid.